Let us discuss LeChatelier's principle. So if you have a system at equilibrium and you disturb it, okay, let's say A plus B becomes C, and right now it's at equilibrium. Let's say you change the temperature and the pressure or the concentrations of one of these. The system will shift. That means it'll either go to the right or to the left, and to counteract what you've done until it gets back to the equilibrium position. Okay, so how does a system at equilibrium respond to various changes in external conditions? First, there are three ways to disturb them that we're going to be discussing. The first one is you either add or remove reactant or product, so you take away A or B or C, or you put more in. If you change the pressure, if they're gas molecules, you can change the pressure by decreasing the container. So if you decrease the container, it's more pressure inside. If you increase the container, there's less pressure inside because they have more room. You can also change the temperature, okay? And this will affect a system whether it is endothermic or exothermic. So those three things is how you disturb a chemical at equilibrium. First, let's go ahead and look at concentration. If you increase the concentration, it wants to be consumed. Okay, what that means is if you have A plus B turns into C, if your system is already at equilibrium and you add more A, it's going to go to the right to consume what you've just added. Okay. Now you can also decrease the concentration. If you take away the C in a system at equilibrium, it's going to go to the right to replace what you've just removed. So it will also replace it. Okay, so here's an example. Here's the reaction. And let's say that you want to make some ammonia. And the more ammonia you make, the more money you make. How are you going to make more ammonia? Well, of course, add more N2. If you add N2, nitrogen gas, this system will go to the right to use up what you've added. You can also add H2. If you add H2, it's going to go to the right to use up what you've added. If you add NH3, though, it's going to go to the left to use up what you've added. Okay? Now, what if you remove the NH3? If you remove the NH3, the reaction will go to the right to replace what you've removed. If you remove the N2, it'll go to the left to replace what you've removed. Okay, go ahead and pause the video and answer the following questions on example 2. Okay, let's look at this one. If you add CO gas, you add this, it's going to the left. If you add carbon solid, I hope that you wrote that nothing will happen. And the reason is it's a solid. If you have a small clump of it and if you add more, the concentration does not change. It's still a certain grams per unit volume. Okay? Remove another solid, nothing will happen. Remove AS4 gas, it's right here, so you're going to remove it, so you have to refill it. So it's going to go to the right. Okay, note solids and liquids do not affect equilibrium. Okay, let's go ahead and look at pressure. Let's say you have some gas molecules, and the gas molecules are in a small container versus a big container. Inside their small container, let's say this balloon is rigid, okay, it can't get bigger. The gas molecule in there is going to have too much pressure and they don't have a lot of room, okay? In a small volume like this, small volume, there is a lot of pressure inside the balloon. A lot of pressure. Okay? In a bigger volume, your gas molecule is free and there is less pressure. There's less pressure in the bigger balloon. Again, I'm pretending that the balloon is rigid. It can't get bigger or smaller, okay? So, which scenario do you think gas molecules would like? A lot of pressure or very little pressure? That's right, gas molecules like to have a lot of room. You have to consider that. Gas molecules love space, so they can expand, okay? Which means gas molecules hate pressure. Okay, and that's all you really have to consider. Okay, gas molecules hate pressure. Okay, so how does pressure affect a reaction at equilibrium? If you reduce the volume, that means you're making a tiny little container. It's the same as increasing the pressure. Okay, this will cause the shift in the direction that reduces the number of moles of gas. Okay, so what that means is if you make it smaller, if you make the container smaller, you're going to go to the side with less gas. Okay, so let me write that here. If you add pressure, another way of adding pressure is by making the container smaller, small volume, you're going to go to the side of the reaction, either to the products or reactants, go to the side with less gas, because gas molecules hate pressure. Okay, let's try this. Here you have CO2 gas right here, okay? If you add pressure, which way do you think it'll go, right or left? Yes, it's going to the left, because you're going to squeeze these gas molecules together and it hates pressure and it's going to turn solid. It's going to go to the left side. Now, if you take away the pressure, that means release this gas. It's going to be very happy, so it's going to the right. If you add pressure, go to the side with less gas. Okay, go ahead and, oh, note, pressure does not affect solid, liquid, aqueous because they are virtually incompressible. You can't, pressure only affects gas molecules. Okay, you try number 2. Here's your reaction. Okay, go ahead and pause the video and try number 2. Okay, so when you add pressure, it's going to go to the side with less gas. Here on the left side, you have 1 mole of gas, 3 moles of gas on the left side. So you have a total of 4 moles of gas on this side. Over here, you only have 2. If you squeeze them together, you add pressure, it's going to go to the right because there's only 2 moles of gas on the right side. If you take away the pressure, it's going to expand and you're going to get more gas. It's going to go to the left. Okay? Go ahead and do the rest of these. Pause the video and do all of them. Okay, so if you add pressure on example 3, it's going to go to the side with less gas. So it's going to go to the right. Okay, ignoring the solid and the liquid. They need to be there, but you don't consider them when seeing what happens when you add pressure. Okay, now you want to reduce the volume. Reduce the volume means small container. That's the same as adding pressure. Okay, if you're adding pressure, you're going to go to the side with less gas. So it's going to go to the right. Okay, add argon. Argon is nowhere in sight, so it would not affect the partial pressure of any of the components, and it will not affect. Remember, if you have a balloon and you have argon in there and PCl3, Cl2, they don't see each other. They don't even know that they're there. So if it's not a part of the reaction, it's not going to affect the equilibrium. So nothing will happen. If you remove the pressure, it's going to go to the side with more gas. So it's going to go to the, wait, this is 4 and 4. Oh, they're the same. So it's going to go nowhere. It'll just stay where it is. Okay. Next, how does temperature affect a reaction at equilibrium? I believe I will use the next video for temperature. For the next video, we'll do temperature and practice problems and catalysis as well.